Welcome to MLOps Live, a podcast by Neptune AI.
We host in-depth discussions where machine learning practitioners answer questions from other practitioners about one subject related to production machine learning and MLOps.
Tune in to get real-life stories, dirty hacks, and pragmatic workarounds from ML people in the trenches. Welcome, everyone, to another episode of MLOps Live. I'm Sabine, your host. I'm joined here by co-host Steven. So this is an interactive Q&A session with our guest today, Federico Bianchi. Welcome, Federico. Today's topic is testing recommender systems. So now it is my pleasure to introduce to you Federico. Welcome.
Thank you very much. Thanks a lot. Happy to be here.
All right. So could you tell us just a little bit about yourself, who you are?
Yeah, sure. So I'm a computer scientist, but during my master thesis, I moved towards more machine learning somehow path of life. And I started doing NLP, and more recently, with the collaboration of Jacopo Tagliabue, we started working on recommender system, or in general, e-commerce, recommender system for e-commerce. We've been working together since 2019 on different tasks in recommender systems. I tried to bring some of my research expertise in the Copio projects, and our, let's say, most recent project is called Recklist. That is this open source package that hopefully we are going to talk about today. That is meant to provide you with somehow a black box interface to testing that you can use to evaluate recommender system models. But yeah, we will probably go into this a bit later.
Oh, I'm sure. And before we do, and before we get into the questions from the audience, just to kind of warm you up a little bit, how would you explain this testing recommender systems topic in 1 minute?
Yeah, so I think that testing recommender system is probably the most important part of your pipeline. It's fundamental to understand if your recommender system really works and is really able to do recommendations as you originally planned. There are different somehow aspects of testing recommenders. One is a more quantitative aspect in which you compute point-wise metrics on the result that could be like hits or the NDCG. Let's say you evaluate somehow the performance or the accuracy of the recommender. But there are also two other, let's say, dimensions that I would like to mention. The first one is definitely the fact that you can also slice your data and try to see or understand how your recommender performs on subgroups. So you just don't look at, let's say, the point-wise metric you get on the entire test set, but you want to see how it performed on specific brands, how it's performed on specific objects. The third part is that you can also evaluate behavioral aspects of users into the pipeline. So, for example, you might want to understand if it makes sense to suggest a television to a user that is buying a HDMI cable, or vice versa. Definitely, if the user is buying a television, you expect that recommending an HDMI cable is somehow a good suggestion because it might be a complementary item. The thing is that this is not transitive. When you do the other way around, it doesn't work. If the user is buying a HDMI cable, he probably already has a television. So you wouldn't actually recommend a television to buy. So there are different aspects you want to maybe explore. And these are, let's say, the three most important aspects, I would say.
Awesome. Thanks, Federico, for sharing that. And I would love also to dig deeper into the behaviors. That's the behavioral side of things. What are those specific behaviors you test for? Especially, say, for example, I've used my recommender system. Maybe I'm fresh into it, and then, I want to start thinking about this thing. Or maybe I just want to start planning around my system. What are those behaviors I should look out for in terms of when I start thinking about testing?
Yeah, so the first one that I mentioned is like somehow these invariant or like non-transitivities of these properties. So you don't want to end up recommending a television to someone that buys an HDMI cable. The same goes, for example, for recommending, let's, for example, imagine a user that is going on your e-commerce and looking for like moderately priced t-shirts. You shouldn't recommend, for example, a luxury t-shirt that costs $1,000, even if it looks the same. So there are some kind of properties that you want to include into the pipeline that more reflect the behavior of the user. So a user that is looking for a cheap somehow t-shirt is never going to buy a luxury t-shirt. And you can encode these in the model by actually use the metadata. So you can look at the metadata and try to find a way to somehow merge your data with the metadata and define tests that cover somehow the kind of aspect. And this is, I think, one of the most relevant examples. The other thing that we actually try to work a lot on is the fact of being less wrong. So there is an effect on, there is somehow behavioral on suggesting wrong items or suggesting less wrong items. So imagine you are another user that is looking for a movie and is looking for a romantic movie. There is a difference between suggesting a comedy movie and a horror movie. There are things that are less wrong. A comedy movie in this context might be less wrong because one that's looking for a romantic movie might not actually want to see an horror movie. So you might want to implement this kind of behavioral pipeline that look at how to be less wrong. And you can do this with some sort of similarity metrics that allows you not to be too wrong when you do this. And if you just look at point-wise metrics, for example, quantitative metrics, for example, the hits and the NDCG, this will only tell you how good your model is, but not how bad it is when it goes wrong.
Right. So this, from what I get, it's use case specific, right? So for this particular use case, these are the behaviors you have to test for.
That is also an issue. Like this requires domain knowledge. So everything starts with the data, and you need to take a look at your data and start to ask the correct question. You can somehow scale these using the metadata because you have, for example, prices in the metadata that you can always somehow combine with your test. But you definitely need to look at the data and see which question might be wrong. It requires a bit of more effort, let's say, to build up this kind of thing.
Right. So working from the business problem, like what would your users do, or what might irritate your users and things like that, to eventually the technical side. Cool stuff. Thanks for answering that. And and I think one other question that's sort of really crucial, I would say, is that we talk about testing, model testing every time in the MLOps space, right? And testing recommender systems, of course, are going to be quite different from testing other systems. What are those differences that you think we should highlight? Like from maybe I'm testing recommender systems, but obviously there are different ways. It's quite different from testing, say, computer vision problems or solutions or things like that. What are those differences you would want to point out?
Yeah, so let's say that the main pipeline is similar to other ML models because it's still train, validation, test. There are a few things that you want to somehow ensure. For example, if you have a recommendation somehow system, rarely these things are not time-stamped. So you need to take into account the fact that there is a flow, a sequence in your data. And when you do, for example, train, validation, test split, you need to ensure that there is no data leakage, for example. This is one element of different, but it's common to time series, for example. There are instead like some specific aspect to recommender system pipeline that you might want to find a way to deal with. The first one is the cold start problem. So it might happen that you have a new user that hasn't rated anything, and this happens, for example, in session-based recommendation, and you need to find a way to quickly get the most information out of it and try to predict relevant products or relevant objects for him. The second thing is that recommender, since operates with user, can occur in some kind of reputational damage. So if you do wrong recommendation, people might not be very happy. And like it's known that if you do bad recommendation, people tend to leave the platform or like might not be happy. So there is like there are things at stake here. Like you need to ensure that your recommendations are meaningful, otherwise people are gonna leave the platform. And that's why some of the testing is very difficult. The last part is that like recommender system are somehow more a family of use cases. And so it's not so easy to point out an exact somehow testing pipeline. It's not like a single task, like, I don't know, sentiment classification. It's more a family of use cases that are brought under the same name.
Awesome. And we've been talking about pipelines a little while here, and I would kind of love you to sort of walk us through a typical testing workflow. When should I start thinking about testing if I'm building a recommender system? Should I start thinking about it from the moment we are in the data gathering stage, or how or is it sort of like a culture, this test-centric driven culture that we build around the way we build our systems?
Yeah, this might be like very personal opinion, but yes, you need to start as soon as possible to think about tests. The sooner the better. Sometimes it's better to think the test and then develop the model, because the model could be like a simple baseline model that can be like very easy. But until you have an evaluation stage, you can't actually say anything about the model. So I would start the sooner the better and try to think which are the possible obstacles, the possible subcategories, so let's say slices of the data that might perform differently. What we found is that, for example, in some use cases, some recommender perform differently on different brands on e-commerce. And that makes a huge difference when you recommend things. So if one model performs better on one brand and the other one to another brand, you can now understand that you can use the two different models on the two different brands, instead of using just one that you might originally think is the one that performed better just because of some metric. So yeah.
We have Mubasher here in chat asking, are there any model testing framework, approaches, tools that you like to use, I would guess?
Yeah, so I think I would like to say that we release Recklist exactly for somehow this reason. So we wanted to build a framework that could be included in any pipeline. Recklist has been built with somehow two soul, one that is more an academic soul, and the second one that is more a MLOps soul. You can include it in any pipeline. It's a very simple Python package that you can include in whatever pipeline you have. The other side is that Recklist already implements tests for some of the most common datasets. For example, the movie lens or the Spotify datasets are already there. So if you are like an academic, you can develop your model, test it on standard tests, and use our somehow behavioral tests to see if the model performs as you would like it to perform. But yeah, I think we definitely work on Recklist to create one framework to address somehow this kind of issues.
We have a live question as well from Chris. So Chris, go ahead.
Many live questions maybe, so we'll figure out where things start to flow in the chat. You cut me off. As I said, in our company, we are pretty disciplined at testing of the primary code, the client-facing applications, but from an AI standpoint, we are stereotypically weak in that regard. And we were just this morning talking about how to fix that with some production errors. How do you whittle down the priority tests? I could start to write down maybe 50 different things I should test, but that's just not feasible with such a small team.
Yeah, that's a very good question. It's also a very difficult question, to answer completely. The best thing to do is to look at the data and see where things do not seem to work. It's obvious that you can use online methods to understand the click-through rate to better view, which is the current problem. What we usually do is that we do some error analysis and we try to understand where the problem are. But yes, it always boils down to actual exploration of the errors and seeing where things are going wrong.
It feeds into an extension of that. How are you finding these? Are you discovering them by failure during some other offline testing, or are you sitting there and brainstorming your concerns?
Yeah, both. Some are offline, things that come out from offline testing, in which you see that by slicing. One example is the one we had before, that we saw that by slicing the data on brands, we saw that the model doesn't work on some brands. And yes, this again requires some sort of like brainstorming. But the second part is, again, yes, we need to sit down and like trying to understand which are or like come up with some possible tests or check some possible issues manually by brainstorming. Yes.
And is that where you pull in your SMEs in order to have that conversation?
Yeah, I would do that. Like I'm not an MLOps somehow expert, but yes, that would be like the way I would deal with this. Yes.
Okay, I'll defer to chat questions for a few minutes.
Thanks for the questions.
Thanks, Chris. So we have a question here in chat from Patricia. Is there a space where outsourced human experts, like data labelers for classification problems, could be helpful in testing your model?
Yes, definitely. Like going on Enter and making people evaluate some of the prediction is something you can do. There is like one problem. Obviously, it is always difficult to understand how the user rate things, and always it's like including making proper evaluation on Enter is always difficult. But yes, definitely like including this into the pipeline can be something you can do, but it's also like a very costly operation to hire annotators to fix let's say to fix some of the testing errors. And also like again, it brings to the table how do you select which example to annotate.
I would love to know what is sort of like your process for designing these problem relevant like test suites. So you know for sure that this is the domain I'm working with. We talked about the domain earlier. We talked about the use case. You select that use case. What's your process for thinking about the use case and thinking about the test suites that will be suitable for testing such use case, from the data to the model?
So you mean how do you come up with the tests?
Pretty much.
Yes. So that's like we said before, that comes from brainstorming and trying to you need to know your data. I think that everything starts from the fact that you need to know your data very well. You need to know which are the use cases, why users are online, what are they doing online. So you need to start from that. You can definitely, the first part would be like to somehow, the first tests are the standard offline tests that are NDCG, and it's measured to understand if the model performs better. But then you need to think of which are the use case of, let's say, your end user or of the client for which you are building the model. That could be also yourself. And one example is to reconnect to what we said before. If your client is building specific marketplace pages for different brands, you want to first evaluate how well the model does on all the different brands to be sure that actually the performance is okay and reliable. So yeah, it all boils down to sitting down, looking at the metadata you have, and seeing which are the properties you want to keep. Some properties are pretty general. The invariant property of the cost, it's a property that you should keep always, but also like being less stronger. So checking how bad you go when your how bad the model goes when it suggests something wrong is something that applies to any use cases. So there are some general things that you can always have in any kind of recommender, but some requires you sit down, look at the data, try to understand which are the possible things that can go wrong, look at the metadata, see which are the properties you want your model to keep.
Chris, go ahead.
Yeah, as I said, I'm writing them down faster than I can think of them, it seems like. Okay, so I think the next real priority, we're finding that in our product, low probability recommendations are worse than saying nothing. So are you having that problem, and how would you test against that?
Sorry, for low probability recommendation, you mean?
Yeah, so we're generating probability and confidence on what we ultimately recommend to our client in terms of what our product does, and they get mad because the recommendation makes no sense, and so we're moving towards just saying nothing, right? Blank. So we have no recommendation for you. Is that something that you do in terms of recommending product to customers, and if so, how would you test against that?
That's like a very interesting question. We had a similar problem, and what we did was like when the confidence was too low, we replaced that with like most frequent somehow recommendation, and that seemed to somehow it's somehow a baseline you can use to somehow protect you from not recommending anything, but it might not adapt to your case. But yes, I don't have in mind how I can think of a test for this. I would need like to sit down and focus to actually understand which is the best way to deal with this, I guess.
Good answer, because it makes me feel better. Yeah, because I've been brainstorming. I'm like, I don't know how to do this right now. So, and then, how do you prioritize and identify the recommendation mistakes that you are testing for?
Like, for example?
Well, I mean, you're trying to recommend the $1,000 T-shirt to somebody. That's one case. How do you identify the other priorities if you have a strong enough population? How do you figure out where you're making the mistakes, and that those should be key test cases?
Yeah. So again, the thing is that you need to, like, we were able to do this because we knew the data, and so we could go into the data and see, for example, this kind of that we have the price, and so we don't want to recommend the price. You can also like have some kind of ask the user to give you a feedback, but we know that like users don't tend to give explicit feedbacks too much. But yeah, I think that the best thing to do is like a metadata wise and kind of analysis to get this. And this is how we somehow find that implemented this some kind of constraint on the data.
All right, so I'll keep going for a second. So this is a multi-part question as well. So the cost of test development is now hitting me. Right. So we have expectation of delivery time, and we have not traditionally baked in the development of testing. So I'll give you 3 different pieces here to maybe talk about. What are the resources that you allocate? What's the human cost? What's the delivery time cost of adding this requirement into the development cycle? And then, do you use experts in test development, or is it the AI team that's required to kind of learn this skill and go off and do it?
So yeah, I think I'm a bit not prepared to answer the question because I'm like not the MLOps somehow guy that handles this. But yes, I can understand like that there is a huge cost in dealing with this, and there is like somehow a very hard somehow cost in dealing with all these resources. What we try to do when we actually propose Recklist is to provide a way to decouple somehow the implementation of the model and the test. So you can use Recklist with any kind of model and then implement your test. And that should at least somehow tackle a bit the cost, because you don't have an actual new pipeline to build. You just need to implement a wrapper in our platform and then use it.
Okay, so in that last part that I was asking, so your MLOps team, do they have experts in test development beyond if a use case isn't in Recklist? Or is the data science and the AI team having to learn that skill and do the test development themselves?
I would have to ask to the MLOps guy I'm working with, that is actually Jacopo Tagliabue, that was, I think, here a few months ago, because I'm not taking the lead on that part, actually. But we can maybe chat later and discuss this probably.
Okay.
Yeah.
I have more. Okay, I'll keep going. You can cut me off, whatever. So do you test against like problems like distribution? All right, you've got I assume if big enough population, you've got a fairly normalized distribution of recommendations for different products. Is that something you would consider as a necessary test?
Yeah, you also have like long tail distribution problems in which you would like to understand the coverage somehow of your recommendation, and that is something that is already included in our library. So yes, it's definitely something you want like to tackle the frequency, and because we know like frequency is often like one of the main predictors. So yes, definitely.
And does that end up creating a break in the release, or does that create an alert to the team that something has shifted?
So currently you can treat it as you want, because like what we do is that with each test we somehow save the artifacts that can be somehow read with a machine-to-machine communication. So the idea is that you can use this, do the test, see how it goes, and then have somehow threshold metrics that tells you and sends you like somehow some notification about this. Currently, we don't enforce this kind of behavior. We just stay on the test part and save the artifacts. But yes, definitely something to look interesting to looking into.
Awesome, thank you.
Thank you.
This is cool. So I think I'm done for the moment. I've got others, but they're kind of sub questions. So.
Yeah, awesome. So we have a question that was submitted earlier, and this person asks, "What's the quickest way for a team of two, one data scientist and one software engineer, to start incorporating the culture and process for testing their recommender system?" So they've deployed a very basic version of the recommender engine, but they want to start thinking about testing because they haven't done this before. So what's the quickest way what's the quick win that they can get?
So there are two directions. The first one is the more quantitative side, in which you need to just implement metrics and evaluate the performance of your recommendation. You need to look at like what the data you have and see how users react. If you have an online system, you can obviously look at the click-through rate and all the other online metrics, A/B testing. But definitely what I think what we are trying to suggest with our work is that you need to sit down, look at the data, and try to understand by working with product people, using the user studies, trying to understand which are the desired behavior that your model should have. So there is this somehow step forward that we want to do that starts from, obviously, you need to do your train test validation using quantitative metrics, but we want to move to a more behavioral-like evaluation. That is what I would recommend. So first start, obviously, with the quantitative, but think the sooner the better you think about this more general and more behavioral kind of test, the better.
And speaking of small teams, or what we call reasonable scale teams, what's when it comes to like testing recommender systems, what's the difference between when you're doing this in a small team and then you have a handful of models and that form your recommender engine, compared to when you're doing this at hyperscale companies like, say, Netflix or Amazon? Because I imagine at Covio, you encountered this earlier on. So what was the experience? Like, what's the difference between doing this at Covio and probably doing this at Netflix or so?
Yeah, the data and the resources are what makes testing obviously difficult. Like, big data is always different from reasonable scale data. You can implement ML pipelines since you have data, but obviously there is a big difference on the quantity of data. And at large scale, what we know from like the people we talk to in big companies is that is also difficult to scale the tests. If every time you run a test, you need like to run through 1 billion of points, that's a huge cost, and it's very difficult somehow to take care of. And actually, we know that one of the problem, one of the some client Covio worked with at was that they had somehow a lot of data points about watches, and the model was suggesting cheap watches when the user were looking for luxury watches. And that's another thing in which it's very difficult to moderate, because you have a lot of variability, you have a lot of data, and it's very difficult to find somehow these issues without actually understanding somehow the data. So the more data you have, the more complicated the problem is, because it's more difficult to explore. Obviously, with less data, you have somehow maybe model training problem, but it might be easier to explore your data and see which are the issues in that.
Awesome. And as a quick follow-up to that, we have one follow-up from this particular team, and they ask, what are the challenges they would encounter, or you would anticipate they would encounter when they start out testing their recommender systems, especially since they have a recommendation engine already running in production, which I assume they use like quantitative metrics to evaluate. And so in terms of when they're starting out behavioral testing and black box testing, what are the challenges they would encounter starting out?
Yeah, they might encounter that some of the recommendations they have do not respect their somehow beliefs or their understanding of the model. But that's good. That's something that is actually good, because you can now get that you see that the model is making wrong predictions, and you can fix that. again, the being less wrong characteristic is one of the easiest to implement, but it's probably one of the most important one to use, because it gives you this idea of understanding how bad your model is, and maybe your model is bad on a specific subset of user recommending bad thing, and you can intervene on that and make the model perform better, I think. But yeah, definitely we're going to encounter this kind of thing. We hope with Reckless, we hope to simplify the development of testing pipelines, let's say, because I understand that like testing this kind of behavior is difficult, and testing also this behavior and all the metrics like coverage and all the other pipelines is also very difficult. So that's why we try to simplify somehow this. We decouple the model from the actual test so that you can implement it, and I think that should at least reduce a lot the burden on the team, and can somehow remove some obstacles that are in the way.
Awesome. Thank you.
We have more questions. Fire away, Chris.
I am slowing down. So, so when you find an obvious break case that's new, what is your process to sit down and develop that and then bring it back into testing? And I ask that because we sort of answered that question in the past, bring in the SMEs and talk about it. But some of these break cases can be tremendously complicated in terms of the data set. The data might involve PII and problems like that we're running into.
So you mean how do we fix the problem?
Well, fixing the problem, go fix it, right? But then how do you develop that into a break case so it doesn't happen again?
Yeah, that requires you to adopt some strategy to train the model in a meaningful way. You can also like do some post-hoc ordering. That will be some sort of a stitch solution, but it would work. So, for example, in the use case of the recommendation or the testing, if you know that your model tends to suggest pricey item, you can somehow apply some sort of reordering. That again is a post-hoc solution that might not work in all cases. Otherwise, you need to go back to the training pipeline, trying to understand where the model is learning this kind of feature, try to see if you can input that feature in the model and retrain it so that it doesn't happen again.
Are you using some form of version control, say DVC or something like that, in order to manage the data that's necessary for that testing?
I know that the guys at Coveo use some sort of versioning, but I'm not sure, and I don't remember probably what it is, but like I'm happy to post it in the chat later so you can see that.
All right, one last question I have, I think, although more appear the more you talk. So, and I'll answer a little bit of somebody else's question. So right now we have Circle CI, and it has a test platform in it, but we are manually writing tests. I'm interested in looking into Reckless. We're moving towards Harness, same kind of thing. Those are both DevOps solutions, right, that are used by our SE team. We're trying to brute force our way from an AI and ML standpoint into these DevOps solutions. Is Reckless the answer, or that you use, or are you doing other things to get away from those traditional CI/CD platforms for the testing?
So Reckless should come somehow in the somehow platform for testing, because it is a testing environment. Currently, it's an alpha, so we are right now trying to talk to some people to work together to move to a more beta version that can be more powerful. But yes, we still plan to use this in a somehow continuous integration development environment. One thing I can post in the chat is this link. Jacopo actually worked on an entire stack that include Reckless for recommendation. It uses like somehow Snowflake and Metaflow to combine all the elements, also like experiment tracking. These include Reckless as part of the testing pipeline, but it's just an example of how Reckless can be used to do this somehow work.
Awesome. Okay, thank you.
Thank you.
All right, we have another question from Patrizia in chat. How often do you need to update a typical, for example, e-commerce recommender system, especially when availability of products you sell or recommend can change on a daily basis? Do you need to have a human in the loop for every update, or some of the updates are fully automatic? Maybe changes in the product availability doesn't imply a need for updates?
That depends a lot on the use case and on the data. Like, I don't think there is an actual easy answer to this because a movie recommendation website behaves differently from fashion recommendation, in which there is seasonality, for example, and stuff changes every 3 months. So it depends a lot of when you see your model start not performing well, you need to train it again. And you need to balance this with the cost, obviously, because otherwise you would train that every day and use a new model every day. So I don't think I have a real answer to the question. It depends a lot on your use case and how variable is the different somehow the different products that are in your setting.
Awesome. So we have another question that was pre-submitted as well. And this person asks, does testing production recommender system also account for testing the data coming in from somewhere like, say, the feature store or the data warehouse? They've been thinking about model testing, but also anticipating that the quality of their data could also fail them at times. How do they account for both testing the data as well as, the models in their system?
Yeah, so currently testing data is something that, for example, we don't directly have in Recklist. We could implement some tests to evaluate the data, but that's on somehow a different level. But yes, I think that like testing the data is obviously the most important part, and you need to make sure that the data is absolutely not too noisy, that you have a good representation for each, for example, sample you want to recommend. Otherwise, you don't have enough data. Because as we know, if you have bad data, an okayish model and a good model will perform poorly. If you have good data, also the okayish model will perform very well. So yeah, data quality is probably the most important thing to take care of. And there are different ways to look at this. One is the one I said, like looking of how sparse is your representation for the products, I guess.
Right. Another question in chat. So first, I will give a bit of context for Wilson's case here. He's saying, we do weekly grocery meal deliveries with a relatively small set of available products, less than 500, where customers are expected to order some products repeatedly, for example, staple grocery items or recipe ingredients. And ideally, we'd like to predict what a customer would want to receive on any given week and learn how often they purchase a particular product. So the question is, Wilson says, I read that Recklist supports session-based recommendations for looking at a customer's behavior across different sessions. Do you think this would support a subscription business situation?
I think so. We need to probably reimagine a bit the way we do and import the data sets. Currently, most of the work we did was on session-based recommendations. So Recklist is strongly focused on this kind of setup. But since we are moving onto the beta, we are reshaping the abstraction of Recklist to include this somehow more use case. So definitely, yes, we would like to do this, and we would like to find a ways to evaluate this. I would be like super happy to chat about this. If you want to send us a message later on the Slack, I'm happy to interact a bit on this.
Awesome, thanks.
I just want to get to this question that we were given by someone from Reddit, and this team is currently running a batch recommendation system, but haven't started thinking about testing beyond, model evaluation. Due to an additional use case, they've now started working their way up to implementing a real-time system. This team wants to know, are there any differences that they should be aware of between how they test batch recommendation systems versus online recommendation systems?
So yes, so I think that the answer lays in if there are differences in the use case. Like if the use case remain more or less the same, there are not, I think, big differences. Still, the evaluation looks mostly similar. You're still evaluating the stuff. Like there is this abstraction of the model that does a recommendation, but then batch-wise or online, you still have a similar output. The thing that is different is the use case, because when it comes online, there is a session to take care of. So that makes the test different. So just to recap and answer the question, there is a difference only if the use case changes, introducing new elements, for example, a session in which you need to then take care of, like somehow this kind of sequentiality or frequent somehow or rapid update that you need to give to the model in the test set.
Yeah, I'm sort of thinking, does the testing affect the latency in some way?
You mean the test?
Yeah. Does the test, like if I'm running, say, my test online, for example, maybe like for an online system, does that affect the return, how fast the results will be returned for an online system?
If you run the test online, you usually are going to pay the price of like some sort of latency. What you might want to do is to run that offline in a continuous integration and development pipeline, in which you can somehow run the test, get the validation from your metrics. And then since there is all versioning, you can have like a set of models with all the results. And then you pick the model or the models that perform better and that you can use in a more reliable way. So I think that's surely using online is gonna be pay a huge price, but like in general, also online recommendation is more costly in the sense of latency. So combining this with the test would be like very hard to I think use together.
And you spoke about versioning in this case. So I'm wondering, do you have any thoughts on how I should version my test suites, in terms of how I use them and, how do I report and share those like results themselves, or are there anything around?
So yes, definitely. So the machine-to-machine communication is easier. You just need to save in a coherent format, have an artifact that you can store on S3 bucket probably, and then you can query it via API and understand which model is better. What we found out that is very difficult to find a way to do some kind of sharing and understanding with humans. So we tried to build a web app in Rectlist that would allow you to look at all the metrics, see the different plots, try to understand what changes in the different representation. But that was very difficult to do. Like there is a lot of variability and it's very difficult to provide a meaningful way to share this kind of versioning and report to humans. So what we are instead trying to do is now focusing on more including the pipeline in this somehow orchestration or experiment tracking, like Jacopo did in the link I shared, because we want to use the best feature of other tools and include them somehow in our representation.
Awesome. Do we have any question from the community? Because there's one more question from Reddit. Okay, let me just share that. And okay, just before I go into that, of course, we know that for recommendation systems, you have like your ranking models. You're either using your ranking models, your retrieval models, or maybe combining both, however your engine is built. So I would love to know, are there any differences between how you test your retrieval models versus your ranking models for recommendation systems?
Yeah, I mean, yes, in the general sense that, yeah, obviously, when you do the candidate somehow selection, you need to, for example, somehow evaluate how many things you are not considering. So yes, there are differences because these are two different tasks, right, but these are not like fundamental or solid differences. So you can still use similar metrics, for example, the coverage, and instead for probably the ranking, you want to use NDCG or the mean squared error measure to better understand how close is to your result. If instead we talk about somehow more behavioral tests, that's a bit difficult to implement with somehow the double pipeline if you want to somehow to evaluate only one of the single, because there is not a somehow really close interpretation of behavioral test, I think, for a retrieval model. One thing you want to check, obviously, is what you leave out from the retrieval, I guess. That would be like something that you would definitely need to look into, yeah.
Awesome.
I warned you. Okay.
Go right ahead.
Yeah, I mean, this is a conversation for us right now. So you're probably not solving this because my guess is your data is more sparse than what we're dealing with. Just to set the stage, we have X customers. They could have, 10,000, tens of thousands of open sales opportunities. And then we have the underlying information to help make recommendations based on that. Not even close to feasible to test against everybody and make sure we're not causing shifts in distributions of our output. Do you or would you then pull sample data across the population? Do you sample which customers to test against to, try to protect against shifts in behavior?
Yeah, I think the only thing you can do is like sampling and try to understand the behavior on a sample. It's probably not the perfect solution, but I totally understand like that. If there is too much data, you definitely cannot try to do this on all the data you have. So yeah, the only thing I would do is like we had a similar thing, not for a test, but like for actually training a model. And yes, we had to sample eventually.
Sampling down the population or sampling the amount of input on individuals?
On the population, yes.
So the other way that I could think of would be a trusted set of accounts or individuals. Have you thought about that? And what are the traps if you were to go that way?
It depends if your trusted set of individuals is representative of the population. If it's representative of the population and you don't think you're going to have biases after the check, definitely something to look into. But when you take like bias sample, there's always somehow the issue that you end up with like some kind of distorted metrics. So that would be my only fear when I select a subset. It depends on how much trust you have in that set, I think.
Okay, I got one more at this point. And I'll tell the audience straight up before I ask this question, I am not even a customer of Neptune. So this is not a Neptune-based question, but this podcast is hosted by Neptune. So what is your use of Neptune in this process?
So currently not using Neptune. I've been using experiment tracking so I know the experiment tracking somehow set up. So I know a bit how to do this, but I'm not using Neptune right now. So I won't give somehow a very valid opinion on this.
Okay, so independent of the Neptune question, you are using experiment tracking. Does that inform or feed into the testing process?
Yes, it more fits into the training process definitely than in actually the testing, or let's say the reckless testing. But yeah, definitely I use that a lot for research generally. So yeah, I use that a lot, and I use experiment tracking. Like since I discovered experiment tracking, I now do only project in which I use experiment tracking to better understand what I'm doing.
All right, thank you.
Thank you.
Awesome. Yeah, let me bring out one question. I'm not quite. You just let us know if this is like a football. We have this team that asks, "What's your opinion on using managed recommendation engine services like the Google Cloud's recommendation AI products? Do you think it's a great start if they are just starting out to build an MVP for a recommendation system, or should they focus on building something else?" So I presume that this is like, do you also incorporate testing in such services, like since it's like not something you've built? So
yeah, so if you don't have anything that is too somehow mission critical or like privacy issue, starting from one pre-made solution on cloud is definitely a valid option. I still would somehow suggest to try to do there is more in-house MVP in which you have, like, for example, very simple neighborhood search-based model on dense vector that is like very popular right now to just run word embedding skip-gram algorithm on sequence of data and then build your somehow recommender out of that. They tend to work pretty well because you eventually need a baseline on which to compare the cloud service on. Otherwise, you can never understand which is its performance. And yes, it's important to test those. We actually tested those, I think, in the reckless paper, and showed that obviously there is a variation on the different subsets. So yeah, I think it's a good solution if there's not anything mission critical, but definitely I would suggest like try something low effort that you can easily deploy, and you can actually assess somehow the entire difficulty of your recommendation setup.
And I'm sort of thinking, would that help help us understand the behavior firsthand, or you think it's something that's worthy of helping us understand the user behavior first, and then we'll go on and build something in-house, or that doesn't really help in any way?
I don't think it doesn't change much, but I think that like working on your data first gives you idea about the possible behavioral aspect you wanna, because you can play with the data yourself, you can implement the models, see which are the general bias, see how it reacts to frequency, that we know is one of the things that actually affect a lot the distribution. So yeah, definitely, I don't think it's like super important where you start, but definitely I think like a small model in-house that you can actually work on and study, it's definitely a way to start doing, or let's start understanding tests better. Behavioral tests, sorry.
Awesome. And for you, what's like the hardest and not really maybe hardest and the unresolved problem in recommender system testing today that you think that Reckless did not cover?
So there is one. There are different issues related also to behavioral factors that are difficult to cover in recommendation. One that I think I want to mention is definitely the fact that there is a bit of like bias when a recommender somehow recommends product A to a user and user clicks on product A. So the model now thinks that A is a good product and is also has like some kind of bias because A was proposed. So there is this kind of position bias in which there is this self-feedback on which the model somehow fits on. So it proposes something, the user click on something on that, but you don't know if the user clicks on that because it was a good suggestion, or just because it was the most relevant he could find, but not the perfect thing to suggest. So definitely this is a big issue that is difficult to tackle because there is this bias, and there are somehow different kind of thing that you would like to do. What you would like, and with Jacopo we discussed this a bit, it would be nice to have an evaluation setup in recommender system that looks a bit like reinforcement learning, in which you have your somehow recommender that is an agent, interacts with the environment, but then it gets the feedback, but it also like somehow does a bit of exploration. Because you want also to explore the space, not to focus only on the items that the user has clicked. So I think that definitely would be something very interesting to look at. But obviously, thinking of a tool like the OpenAI Gym, that is the main somehow benchmark platform for recommender system would be very difficult, because recommender system, as we said before, are a family of system, have a different setup. It's not really easy to implement the same thing. But yes, the general idea would be like to cover that.
Awesome.
Yeah, I think we have time for this chat question that came up from Wilson again. So it's a follow-up question about RecList. From what I've read about recommender system best practices, specifically at Spotify, the best way to evaluate the effectiveness of a recommender model is to have an ongoing control set that gives out random recommendations to customers to see how they perform compared to actual recommendations. But Wilson says that's not feasible for our business because a large percentage of our customers don't even look at or edit their recommendations before the order ships out. So there's a good chance that those random recommendations would lead to actual purchases and unhappy customers. So do you think RecList could serve as a substitute for this type of setup?
I think this goes more in the general somehow evaluation. So you need to come up with a text that does this. I don't think this is an easier problem to solve. Like suggesting random somehow recommendation is also costly because you select randomly from the set and you don't know if that is going to actually bring to somehow a click on a listening on the platform. So I wouldn't be. I don't think I have in mind a way to solve this, but yes, you can somehow try to come up with a test that covers this aspect and see if that solves somehow the issue. Yeah.
Thanks, and thanks, Wilson. And we have another question from Mathieu. You mentioned earlier about an issue about long-tail distributions. How do you deal with such distributions, and are there any other distribution functions that can be common and cause issues?
Yeah, I think like the long tail distribution is the most common one, in which you obviously have less somehow frequent problem. I don't have order in mind currently, but probably they are gonna come up when I finish the talk, obviously. But to cover these, you need to better understand the coverage of your recommendation engine to understand if the model is actually recommending that long tail, and see if you can actually switch somehow the behavior. So you want to know if the model eventually recommends one of the long tail items, or if those are never gonna be recommended, because this feeds back into the discussion we had before about the model self-feeding on its own data. So if you just recommend the frequent items, then the model is gonna overfeed on those and never recommend those. And again, one of the methods to this is or randomly picking from the long tail, or trying to find a way to suggest only long tail items, for example.
Last words, and what you think every practitioner should know about, recommender systems that most practitioners don't know about. Maybe if there are things beyond testing you want to talk about, just a brief overview.
So maybe practitioner now know. So I would say what I would have liked to know when I started.
Right.
And the most important thing is that data is king, and data is more important than the model that itself. So that is something that is definitely, it's the most important part of the process. If you need to start to work on recommendation, you need to start working from the data. And that's something actually I didn't understand at the start, because I was looking at models, I was looking at the literature, and so like these beautiful models that you say, yeah, these models work great, then maybe you try it, and on your use case it doesn't work because you don't have maybe enough data. So you need to, the most important part is definitely the data. And the other thing that I for long ignored is that testing goes beyond the standard pointwise metric, like it's, for example, and going beyond these metrics and go into the behavioral. This is something we got the inspiration from an NLP paper of 2 years ago that's called Beyond Accuracy, that tries to do somehow behavioral testing for NLP. So the idea is that I think that what I was very focused on at first was pointwise metrics, so getting the best NDCG, but actually there is more to recommender system testing than actually just pointwise metrics.
Awesome. That's all from me. So thank you so much, Federico.
Thank you.
All right. Thanks to everybody who asked questions. So before we say goodbye, Federico, where on the internet can people find your stuff, interact with you?
So let me share maybe I am pretty active on Twitter, so it's the best way to contact me is just to send me a DM, I think. Said I am on the Slack channel, so feel free just to send me a message, and we can. I'm happy to chat and discuss about this.
Yep, just to reiterate, any questions that you didn't have time to ask, or any questions you want to submit in advance for the next show, you can post them and reach out to us in the MLOps community Slack. And final reminder that the podcast MLOps Live has been officially launched, so you'll be able to catch up with the episodes of these Q&A sessions on your podcast service of choice. So we'll be back as usual in 2 weeks, and next time our guest will be Danny Lebzon, and the topic will be navigating ML observability. So I will see you guys. We'll see you guys then. And until then, take care. Thanks for joining. Bye-bye. MLOps Live is brought to you by Neptune AI. Remember that you can join us live at the next event and ask your questions. We run it every other Wednesday, and you can register at neptune.ai/events.
And then make sure to search for MLOps Live in Apple Podcasts, Spotify, Google Podcasts, and anywhere you get your podcast. Click follow and don't miss any episodes.
Thanks, and see you next time.